everybody. Let me quickly introduce myself. My name is Pablo Barron. I'm founder and CTO of a company called Instana. We are building a APM solution slash observability solution slash monitoring solution for specifically modern architectures for Kubernetes and container-based workloads. And what I'm going to talk about today is how to apply observability in the enterprise at scale. You probably have heard about the topic of observability. There are specific challenges in the enterprise and also the necessity to apply the whole topic. And I will explain, hopefully understandably, how to do it, why to do it, and where to pay attention. Okay. So there's a few changes in the modern enterprise that need to be taken into consideration when speaking about observability specifically. So first of all, every modern enterprise IT is kind of forced to think and work like a startup. What does that mean? It means that you kind of need to establish a few garages to verify ideas quickly, to get early feedback from your customers, and to learn how to deliver fast, how to move fast, how to, once the test of the idea doesn't work, you kind of pivot into something different. So effectively speed up all the things and then relax all the things, not write things in stone for too long. Well, on the other side, there is pretty much not a single business in the world anymore that is free of competition. If it's not competitor of your size, like the big enterprise versus a big enterprise, then it is a whole bunch of little startups who is going into your direction, who's going into your business to effectively steal some segment of the market, which is a good thing, but it is a change for an enterprise who probably 20 years ago didn't know and didn't learn how to work this way. And the technology is being defined, invented, and pushed from somewhere else, not from the enterprise world right now. I mean, of course, there's a lot of research going in classic enterprises, for sure. But, you know, pretty much a lot of technology these days is being introduced and pushed on you from the side, from somewhere that you cannot really control. And you kind of need to follow this trend because users are not paying attention to, you know, long wait times, et cetera, they got really picky. So you need to serve them. And this means that you need to follow the path that somebody else defines for you to work in your market. Well, there's not only challenges, there's also changes that happen to the modern enterprise IT. Sorry. One of them, well, or a whole block of them, is effectively around variety and the lack of visibility. What I mean by that is that a classic enterprise, of course, is expected to have a whole zoo of solutions that have been created at different times. Some of them are maintained, some of them are less maintained. Most of them pretty much are still in place, and a classic enterprise IT architecture wallpaper is pretty big. You can wrap around this poster, you can wrap around a room wall, like all the walls in the room with them. I've seen this all. And on the other side, having all this introduces a huge challenge on visibility, how to understand the states of the particular things in this whole wallpaper, how to understand their relationships between them, how to understand who impacts what and how. All these different solutions created at different times by different people, by generations of people probably. It is a huge challenge to the IT and also introducing everything new, as I said, with the changes that are happening, contributes and piles up on top of it continuously. On the other side, I mean, if you're in a big enterprise, you already are drowning in data, I mean, for years. And everything that changes market-wise right now, and from the perspective of the user behavior, from impatient users, all of the expectations they have on mobile applications, et cetera, it introduces way more data. Now you're already overloaded, so you don't want to add on top of this overload. What you want to focus on is useful, reasonable information instead of really raw data. It's really enough. What makes an enterprise as compared to a company that just started, it's not really about the size per se. What it comes with are responsibilities, and those can come from compliances that you need to be compliant with all different expectations, regulations in different countries. This is kind of, I mean, this is due to the fact that you exist for so long and have explored different markets already. On the other side, what you want to do in the enterprise, of course, is establish standards that people kind of follow the same best practices, same procedures. You don't want everybody to reinvent the wheel all the time because it's very, very costly. It cannot be really properly controlled. The effort cannot be minimized. And also onboarding new people in a large setting is very, very complex if you don't follow any kind of blueprints. So enterprises are all about standardizing procedures, the way of work. It doesn't matter how agile, not agile, whatsoever. It is all about having commonalities among the whole large company and following compliance and regulations. What is a very difficult topic? First of all, budgets. I mean, there is a growing need. Well, not really need. Let me put it that way. An enterprise would write their budget in stone for a year, maybe for 2, maybe for 3. The reasons for that is predictability. The reasons for that is the responsibility and necessity to report about budget consumption and plan the budgets for the next years beforehand. It is a pretty complex topic. It comes also with the size and with a number of users in the overall systems. But what also is interesting is that on the other side, the new world, the modern world, is pushing consumption-based, usage-based scenarios and payment on an enterprise, which is a big challenge because on one side you want to be predictable, on the other side you get this consumption-based model. They are absolutely not compatible. So effectively you end up calculating up without the ability to move too much inside of something that you call budget, even if it's derived from consumption-based model. On the other side, in a large company, in a large enterprise, there's a lot of different costs that are hiding. I mean, they start with something that you couldn't predict and is not part of the budget. Especially, it is very possible in anything that is consumption-based. On the other side, hidden costs can be cost of opportunity, as an example. Your people are doing something while not doing something else. So effectively what happens is that as an example from the industry where I'm working in, when people are busy monitoring, they're not contributing to the core business value. So they are not doing what they're supposed to do, and you lose probably the ability to target the market the more people are busy with things that are kind of secondary. And so on and so forth. It is a difficult topic. It is a real big challenge in the enterprise, and it needs to be addressed no matter by what kind of a solution. Another aspect in a classic enterprise or in a modern enterprise, IT, whatever, is of course that you cannot rewrite everything today that you have been running for years. The reasons for that are different. First of all, IT systems that have been working for years and still can be supported and maintained, there is no reason to replace them unless they are not satisfying the needs. But just replacing for the sake of the replacement for sure is not happening, because you kind of need to ensure that your investment still survives, because otherwise you would be multiplying this. This is not responsible. So enterprises deal with a lot of legacy, and everything, of course we know it, everything that you write today is already legacy tomorrow, which means that it piles up. And the more systems you need to implement, the more systems you need to integrate, the more, let's call it legacy stuff, is being accumulated on the way. And the more you need to take into account different generations of different software systems. And of course, people are a big challenge. I mean, as opposed to a startup where people could be expected to work who are more entrepreneurial, even if they are employed, they are more, like into this adventure and risks. But there's a lot of people who are working in classic enterprises that are not like this. They're still they can be real, have high levels of expertise. They're just a different kind of human being. It is a challenge to kind of help them work in a sense that is how it's expected to work in this modern world, to move fast, to deliver fast, to break things fast, start up-ish, and also kind of introduce measurability that startups come up with, anything from OKRs, etc. You name them all. It is a challenge in a enterprise setting, per se. We spoke about changes, we spoke about challenges, but it's not only this. There's a lot of positive upside things, and the opportunities that come with the modern world for the enterprise IT are, specifically for the topic I'm talking about today, are the following. You can set yourself up as a big enterprise for fast delivery and continuous delivery, which is very, very, very core to moving fast and then testing hypotheses very fast, and then changing target markets and satisfying users more and more and more. Since everything is moving fast, you need to be delivering fast and also continuously. And you totally can. There is some prerequisites that, of course, you need to fulfill as an enterprise, but it is a big opportunity and nobody should be missing out here. Another aspect is that helps people to achieve their goals the best way possible, while still being that kind of human being who's more into safety, long-term planning, people who are normally working in enterprise settings. You need, or you want to democratize the information for them. There's a chance to collect everybody in the organization around same abstractions, same domains, same kinds of information. Instead of really letting them work completely independently, you can achieve an agreement based on useful information that is democratic for everybody, and everybody can make their own contribution depending on their own skill sets, but there is kind of a baseline that is common for everybody. And it's a huge change because you make people productive through this way while giving them fun to work. And of course, we see this especially in the current situation that going digital is literally not an option. And not going, digital is not an option. I mean, of course, there is industries, etc., where you kind of need to do physical work, definitely, but as much as you can needs to go digital instead of kind of processes that are still manual, not supported by software. And it is a big chance for everybody, in especially for enterprises right now, because they have a market, they are positioned very well, they just need to move. The more they adopt to the digital world, the higher the chance for them not only to survive, but also to ensure continuity of the business. Now, going back to the observability as such, I want to first look into what is not observability. Well, actually, no. First, the definition, the classic definition of observability. It's being a measure of how well the internal state of a system can be inferred from its outputs. So effectively, it's about turning a black box into a white box so you can look inside, or you can look at this thing from outside, and whatever it tells you, you can understand and also can infer how well it does. It's like doctor, analyzing your body in order to figure out what kind of sickness you might have, or maybe you're just healthy. So what is not observability? It's a whole bunch of things, of course, because I've heard many of them spoken out by different people in enterprises. So let's briefly go through them. So observability is not the same thing as classic monitoring. I mean, monitoring is effectively pretty passive mechanism. Of course, you can make it very intellectual, but it is not the same thing as observability, and we will discuss briefly why not. It's also not just for startups. As I said, everybody needs to think and work startup-ish these days, including the enterprises. So it's not just for these cool boys, it is also for you. It's not a piece of tech, so we cannot say that observability is this tool. That's not it, definitely. It's also not a standard. I mean, there is some growing standards how to make things observable that help, you know, like OpenTelemetry, which is a growing community and a growing set of best practices and effectively code and frameworks and integrations that allow you to make your systems that you implement right now observable. But it doesn't mean that this is the only standard. There can be so much expected in the next years because observability is becoming more and more important. It's also effectively not only for new stuff. You can actually make any kind of system observable. There is different means how you can do it. So it doesn't mean that your legacy systems cannot be made observable or are not observable in the sense of observability already. Also, it's not a buzzword. It's really happening. It's a movement. It's there is a huge support in the community and in companies of different sizes to ensure that there is a common understanding how to make systems observable for everybody to benefit from. And probably the wrongest of all things that you could say is that it's not required, it's optional. I mean, first of all, observability as a topic is not new. It is just with the way we change the way of work, with the way we change how we deliver software, how we write software, the necessity to make this whole system with its little pieces, different workloads, observable is more important than ever. So it is just coming back, and it is getting traction. It is just becoming mainstream. So it is required and it's not optional. So what does observability mean actually for you as an IT enterprise, as an enterprise IT? It's, first of all, it is a design approach. It is included in the way how you design your software if you really want to make it observable. It's the same kind of orthogonal cross-cutting concern, like what you would say about logging in general, like old school logging, or if you would think of security as a cross-cutting concern. Anything around this that is typical for enterprise architectures comes into play with observability as well. You need to design for it if you want to do it proper, or there's other tools that will do it for you, but you still need to take into consideration that something needs to be done there, and it is part of the design that you're doing. It is also a set of best practices. As I said, it is not really a standard. It is a set of best practices. There is a suggestion to work with pillars like logging, like tracing, like metrics that propose to you how you can make your systems observable. You can come up with whatever you want if it is still ensured that your software system is, you can understand how it feels while it is in production without changing it. That's very important. Then your system is observable, no matter what tools you use. But there is a whole lot of recommendations how to use it. It is also a growing ecosystem of solutions and tools. You cannot really say that there is the tool for observability. I mean, it's going to be always like it was the case with monitoring. It will always be a combination of different approaches and different tools. But the ecosystem is growing here, especially around the standards like OpenTelemetry, where effectively everybody can agree on a common set of, well, expected functionality, expected data sources, expected use cases. It is also an enabler for the modern way of work. If your systems are continuously observable, you can deliver and break as fast as you want, as fast as you desire, as fast as your internal processes allow you to do. Also, from the enterprise perspective, as I already said, it will give you a competitive advantage because understanding the health and the performance of the system while it is running in production and serving real users without any modification continuously at any time is better than what your competition is doing. So it makes you really flexible and fast. And of course, what it means, as I said, it is happening. It is already a fact. Observability is not only coming, it is there. Framework vendors are enriching their own code with instrumentation step by step. So you get instrumentation points to look into and to understand how it feels. And you should be contributing from your side, no matter if you do this by hand or if you do it automatically. I will have some ideas a few slides later. So how can observability as such help enterprise IT? Of course, you need to do it right. It's easier said than it's done, but and probably everybody will claim this, but let's look at the few arguments here. So first of all, observability gives you visibility. Visibility is a real pain in any enterprise. Visibility into everything, including running software. We're not speaking about processes and whatsoever. We're speaking exclusively about software systems. This is complex enough, and the visibility challenge is properly addressed by the ecosystem that is built around observability. It's also about control. When you move fast, when you break things, when you collect information, test ideas, etc., there's always a feeling that you're moving too fast. Things are getting out of control. So making systems observable gives you the feeling of gaining this control back again, no matter what level of control you feel like having right now in your enterprise IT, but observability clearly allows you to have this feeling. It is also, if you have a high level of automation, that's very important in the enterprise especially, but also anywhere in the IT. Of course, I don't need to teach anybody here that automation is king. The more you automate, the less human error you're calculating into the whole system. And especially when you move fast, every kind of human error that can happen and will happen will hurt you 100 times. You probably didn't test well enough. You didn't give yourself too much time. You just went out with an MVP. You're trying to solve a real problem with a minimal possible solution. Things will break. They will be continuously broken. The less human error is introduced into this overall system, the more automated it is, the more comfortable it is, the better the result. As I said, testing hypothesis is also very important, but it needs to be done continuously as you go. So you can put little increments and little pivots here and there to verify what works best. And of course, any enterprise can do this as well. It's also about delivering fast, of course, but it's, of course, when you deliver fast, you want fast feedback. You want to be in a continuous loop of getting feedback about, did you break anything when you delivered this 20th deployment like today, right? I mean, probably it's extreme, but you get the point. Instead of delivering every 6 months, you will increase the speed, work in increments, and of course, you need continuous feedback about this. And observability gives you the foundation for that. When the systems are observable, you get continuous feedback because you can look inside. It's also for fast technology adoption. You can verify new versions real quick. You can adopt to new versions of software real quick. Everything is moving so fast around technology these days. And if you want to adjust to this pace, having systems observable and also, respecting the observability points of the systems that you're using, taking them into consideration, is it will allow you to to have a feeling of, well, safety. Let's say safety net, right? End-to-end monitoring. It is. I mean, you want to know how the system performs from the perspective of the user, of course. But it's not just saying, okay, it's slow for the user or not slow for the user. What observability will tell you, it will, if it's done properly, it will give you the explanation why it is slow. So you can really react fast in it. It's not enough to know that something is not working from the perspective of a user in some particular country, right? You want a clear understanding why and how to fix it. So you kind of need a connection between this user perspective and what's happening in your systems. So you want to extract stable semantics, right? And then the abstractions like applications, etc., that will be stable in the same way tomorrow like they are today. Not, it doesn't matter what kind of infrastructure they're built on. So you still can follow the path of the user through this stable thing, and to understand in regards to, like, I don't know, application payment, that the application payment is slow for users, no matter if it's deployed as a classic 3-tier application or if it's running on containers or cloud functions whatsoever. It is important that you understand this really quick end-to-end and infer how to fix it. And also you don't want to sample data, because the thing is that outliers matter. The faster you move, the higher the chance that the baseline is going to be kind of stable. If you wipe out single outliers, you will probably miss the points that are important to you. You cannot really base your inference on just a baseline over some period of time. You will have different trends, seasonality aspects, etc., etc. And also, it's not necessary, if it's solved properly for you, it's not necessary to miss the outliers, and you don't want to wipe them out by yourself prematurely. Which brings me to the topic, how to apply this whole story to the enterprise at scale. So, I mean, there can be different journeys how you can approach this. It's all in your hand. You just need to do it. Here's my personal idea how to best do it. First of all, you cannot really focus on making systems observable that are 20 years old and are caught in kind of slow processes whatsoever. You should try this where you try new approaches, try new ways of work, where you, let's say you have some DevOps initiative in your company. This is the territory where you want to go also with the observability. It will yield the results that will be combined with the way of work, combined with the way to deliver the software, and can be projected afterwards onto your legacy system. So in order not to lose the momentum there, you should be going after a lighthouse project that is kind of in the garage somewhere. In the observability, it's all about instrumentation. Effectively, you have code and you need to put somehow instruments into this code that you can look into this at runtime and infer how well it feels, right? So you need to instrument wisely. So I think that an enterprise should be generally striving for a lot of automation, and the reasons for that I think I explained a few slides ago. But also from the perspective of moving fast, right? If the system, if your observability system, your observability tool gives you the ability to automatically instrument glue code, boilerplate, whatever, that you shouldn't be instrumenting by hand, so why not take it, right? So as an example, of course, I'm speaking of something that I represent and I've built from the beginning with our team. In our own product, we have a draconic level of automation because we truly believe that you should not be doing the work that another software system can do for you. As I said, you should not be prematurely sampling, especially in the beginning when you don't know. I mean, you start off with either a new system or some kind of an existing system that is still not observed. Maybe it's not even observable. So you need to learn, and you cannot decide from the beginning how much data you want to wipe out before it will start making sense to you. or stop making sense to you, right? So you should be collecting and processing all of this data that is collected on observability endpoints and then make the later decision, right? So don't sample prematurely. As I said, since specifically enterprises are drowning in data already, they should move quick from data to information based on some semantics. By semantics, I mean not only stable abstractions, like for example, an application, that is by the way in the next bullet point here. Let's say you have an application, it's called payment, and this application can run on different infrastructure. You can even have 3 or 4 different implementations of that thing. From the perspective of the user, it is still the same application. And you want to also connect these little things like one application, or maybe service is a better example. So how services are interconnected. Semantically understand kind of how a system is built, what depends on what can break what, etc. So this level of information, and also already come with suggestions how to fix things. So not really beginning at zero in understanding everything based on raw data. So this is what you should be striving for, information layer that is built on top of raw data that you probably should not be even looking into because it's going to be too much, it's too low level. Stable abstractions are also pretty good to organize people around domains and different perspectives. So perspectives are where different actors, different players have different views on the thing, but domain should not be optional. If you speak of payment should be the same for everybody. Everybody should have the same understanding of what this thing means, what is it built of, and what happens if it breaks. Is this business critical? Is this not business critical? Shall I get up at 2 a.m. in the morning to fix this, or can I fix this thing later in the day? You cannot do this on raw data, because you will expect that everybody in your team has the same view based on raw data, and of course they will have all different views if they don't work with stable abstractions. Simplification and automation of the feedback and root cause analysis is extremely important. Your observability solution, no matter how it is built, should give you suggestions how to fix, how to get from A to B real fast. Because if it's complex, if it's big, if it's diverse, you don't really have the ability and time to give it all a meaning. When you're trying to figure out a solution for a problem, everything that can be explained beforehand should be explained to you beforehand. So you can really focus on figuring out how to fix this in your particular environment, right? But you know, just seeing a CPU load average that is kind of misbehaving from your perspective is not enough to infer that a business critical service is broken and is impacting. So any kind of shortcut that you can take from A to B during your root cause analysis is extremely important. What is also important in the enterprise, of course, is that people should not be reinventing the wheels. I said this already. The risk when they work with low-level observability data is that everybody will define their own, observations, solutions, monitoring solutions, whatsoever. It is important that you have an agreement how to work with this observability data. And of course, abstractions will help you here. But also, you should not be allowing everybody to alert themselves. Generally, alerting is a very complex topic, and it should be considered team-wise. So you need to alert smartly. Smart alert means that it should be first of all shared among team members. A team, for example, that is responsible for a particular application should be responsible for this in the sense that it is seeing the same things. It agrees that the same things are important. And of course, they will be alerted on the same things. So if one team member is alerting themselves based on CPU load and the other one based on some network traffic parameters whatsoever, they are not in agreement and they are redefining observability effectively for themselves. And of course, they will ensure that their own data endpoints for observability are in there, which clutters the whole thing. So that's why I said that it's important to make this decision early in the design phase. A uniform view on legacy and modern technology stacks, as I already said, when you have a stable abstraction called payment, an application called payment, it shouldn't care what it runs on. Does it run on Kubernetes? Does it run on some cloud in your own data center, whatsoever? It simply does not matter. When you work with this stable thing, this is what you need to be observing. You need to be observing the health of an application. Of course, you should be also looking into the health of infrastructure components and whatsoever. But at the end of the day, this is not what the customer sees. The customer doesn't really care what kind of infrastructure you have. They care about the payment application, if I'm allowed to keep this example here. And last but not least, hidden costs are deadly. They can happen in licensing, as I said. They can happen in when you pay as you go, you don't make it predictable for yourself. You should be able to do this better. But also all kind of manual efforts where people are busy with stuff they shouldn't be doing or are not doing the stuff they should be doing, but instead are defining observability, reinventing the wheels, and doing all this by hand. It is very costly, and if you should after observability, you should not do any of this. You need to make the decisions to automate the maximum beforehand, before you even start the journey. Once you have all this in place, and it's actually pretty easy to do, you just need to pick the right approaches for yourself, but also, I hope I'm allowed to say that you should be wisely looking into tools like ours, for example. I think that observability will work just fine in the enterprise and will create a foundation for further development, further transitions, any kind of transformations, going digital, rewriting software, enjoying a fast delivery and continuous delivery. So everything I spoke about, our recommendations, can be found on our own webpage, and you can run our software for free to check out how it works, how we see the world of observability, how we see the world of monitoring and application performance management. Those are kind of siblings. Just go check out how it works and ask us questions. We are, as I said, very high on automation. We come with a lot of simplifications and shortcuts from the beginning, and you can focus really on stable applications and really measuring what matters in your observability journey. Thank you very much.